someone else.
Yeah, I'm just feeling a little tired and groggy because all that rain just makes you feel sleepy and tired.
I know. We've got another hurricane coming in. Don't know where it's going to hit yet. I haven't watched the weather in maybe 24 hours, so I really don't know. But yeah, I think just taking my 39 homeroom students, I think they're starting to just slow down. I don't know if they're getting tired of school or things in life are just crazy right now, but I don't know. Good morning, Jeremiah. We're glad that all of y'all are here. Good morning, Destiny and Noah and Raven and Tyler and Hunter and Caitlin and Logan and again, Jeremiah. How are y'all doing? Hunter and I are saying, man, we kind of just feel like slugs. I don't know if that's Hunter, that's what you feel like, but I kind of feel like a slug. I'm just slowly moving along.
Well, that's how I felt when I woke up.
But I'm moving. I'm moving. Let's see what Raven said. Hello. Noah says, I feel like there are at least 10 students in every class that are failing. It starts to looking like it's, I know. I was shocked. So I can email. I also have an app on my computer where I can text and I can make phone calls. And so I'm having to go in and add homeroom LC's numbers into my contacts in my texting app. So I'm not having to put the number in each time. So I had to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I had to add 12 new homeroom contacts into my texting app on my phone so I could send them a text, because honestly, texting seems to be the number one way to get a response. I don't think people really check their email like they used to, or they're getting so much email. I think it might be a combination of both. I think we're getting so much email that's nothing, that's not important. So I've been trying to text the last couple of weeks and I've gotten a lot of responses when I'm texting. So I have to make a contact every week with either a student or a learning coach from my homeroom of any student that's failing one or more classes. So that's starting to be a pretty hard task to accomplish. So I'm trying by email and text, and then if I don't get a reply by email or text, I am going to make a phone call. So that's kind of my order. That's my thinking. So just try to think, if I was a parent, what would I rather get? I'd probably rather get a text because it's just easier to reply. So anyway, can y'all tell me, are your classes getting harder? Are your teachers not grading your work? And don't steal any teachers' names, but I am concerned sometimes that students might be showing that they have below 60 because maybe they have some TGAs that are not graded. You know what I mean? And they still have a 0 for those. So I hope, do any of y'all have a low grade just because you have some assignments that haven't been graded, like TGAs? Okay. Y'all's feedback is really important. Jeremiah says he doesn't feel like class is getting any harder. Yeah, no, I get that. Sometimes we just do have things going on. That's good. Noah feels like his teachers this year are keeping up a little bit better with the grading. Gotcha. It's not that it's getting harder. Noah says it's just always been difficult. I know I've been helping my second grade. One of my granddaughters is in the second grade, and she has homework. Like it comes home on Monday and it's due on Friday, but it's like four different things, like maybe a couple of math worksheets and then a lot on reading because she's still struggling with learning to read. She's in the second grade. And so, and I'm just helping one grandkid. I can't imagine. Oh, no, you're taking AP history. Both of my kids took AP history. Let me take that back. My daughter did not. She took dual history, but my son, she didn't love history. My son loved history, but AP, he took pre-AP history in the
Well,
10th
I love
grade.
history, and I'm taking AP history.
How do you like it, Hunter?
Well, I like it because I get to learn a little more in depth.
But I can remember, I don't know how y'all's AP history is, but I can remember it's a lot of reading. Hunter, you just got a big shout out in the chat. Noah says you're the star student of the AP history class.
How am I?
Well, that's Noah's opinion.
Noah, would you mind explaining how I am?
What a compliment.
No one participates as actively as you, and you always seem to know the answer when you're talking with Mr. Armstrong.
Yeah, okay.
Good for you, Hunt.
I actually study on my own outside of school.
I tell you what, I would not be the star student. I probably would not be taking AP history. I would be taking regular history. I am just now getting interested in history. I'm sure, Hunter, you probably could just do a lesson today. I do like to read. I didn't get inspired in high school, and that was probably my fault. But I may have told you this. One of my 11th grade American history teachers, she also taught Spanish. And when the class was misbehaving, and it was never me because I was always a perfect student, but when the class would start misbehaving, she would start teaching history in Spanish, and I didn't know Spanish.
And I wouldn't be surprised if she cursed a little in Spanish.
Hunter, that definitely could have been a possibility. But like, I learned nothing because there were a bunch of goof offs in my room. And anyway, but yeah, I can remember now when my son took AP history, he had the same two teachers in the 10th grade and the 11th grade. And she was like an awesome teacher. Her name was Nina White. And one of my son's favorite teachers. And, you know, sometimes that makes a big difference. That the fact that you like the subject, but people just took her class, even though they didn't make all A's and B's. They just loved it. And I hear Mr. Armstrong is a great teacher also. All right. It's 9:13. We're going to wait a couple more minutes and we're going to get started with something called long division today and something called synthetic division. Yeah, Ryan, that's what I always thought about AP history. It's a lot of reading. So in my high school where my own kids went to school, that's why they decided to have a 10th grade. They just called it pre-AP, but what they did is they took all that reading that they had to do in 11th grade AP and they put some of it in 10th grade. So the same teacher taught the 10th and 11th grade class. So they got to spread that reading material out over 2 years. And it was just something that the teacher had the idea to do it. But I do think that it helped with the amount of material that you have to cover in AP 11. So yeah. You know, I think I would like to take something like AP history now at the age I'm at, because I just don't think I was like mature enough at the time to understand how important history is. So I kind of wish I could just have a do-over there. All right, let me get my act together. I was busy leading up to this class, so I feel like I'm unprepared. But I'm going to put the whiteboard link again in the chat. And if you're feeling a little sluggish or you're just feeling like, oh my gosh, life is just, busy right now, just continue to try to work every single day. Definitely, if you have to drag yourself out of bed, Xander, just get on up and my motto is just keep moving, keep doing, keep trying, keep plugging away. And sometimes I know that, I know I'm not going to school like y'all are, but I have a lot of tasks to do as a full-time virtual teacher. And so, I have my checklist, I have all the things that I'm working on, and I have to break it down into what has to be done first each day. And so, anyway, I just have to like just keep chiseling away. I heard somebody say this one time, if you're going to eat an elephant, then you have to eat one bite at a time. And they weren't talking about eating elephants. It was a situation where my son was having big giant projects at work. He's a mechanical engineer, and he was just overwhelmed. And we were talking to this other guy that's an engineer, because my husband and I are not engineers, we're teachers, so we really don't understand what engineers really have to go through. And this guy, his advice said, tell your son, if you're going to eat an elephant, meaning if you have something huge that you have to accomplish, you can't eat that elephant in one bite. You just have to take, that's what we mean by just chiseling away, doing that, just continue to work, do a little bit of work every single day. But I had never heard that saying before. This guy was an engineer, and so I think he kind of understood. And sometimes as parents, we don't understand what our kids are going through. Even once they get to be adults, we don't always understand. All right, guys, it's 9:17. I don't know how it got here so quick. I am recording. I'm double checking all my work here. All right, let's take a look at our do now. So this is from Unit 3. And the do now is a connection to the quadratic formula. So back in Unit 3, that we just finished Unit 3, we're just now starting Unit 4. We solved some equations using the quadratic formula where we had to find the A value, the B value, and the C value. And then we plug those values into the quadratic formula. So take about 30 seconds if you haven't already looked at the do now. And there's an A answer, a B answer, a C answer, and a D answer. And they're asking, if you were going to do the quadratic formula, what would the A value be? What would the B value be? And what would the C value be? So think about that. I'll give you like 15 more seconds. Let me find where I worked out this assignment. And then I'm going to ask for your answers in the chat. I'll give you a 3, 2, 1 countdown. All right, answers to the do now in the chat. 3, 2, 1. Answer now, please. All right, looks like Noah and Hunter and Melanie and Sarah and Xander and Rahik and Natalia all answer C, and I agree with that. Let me share my screen so I can use my tablet. So what do we have to remember to do before we find the A, the B, and the C? Who can tell me that? What have we got? What do we have to remember to do before we find the A, the B, and the C? Okay, excellent. That was, Tyler said, put all the terms on one side. So I always like to go to the side. You're probably, let me rephrase that. You always need to go to the side where your x squared term is positive. So that means since the 5x squared is positive and it's on the left-hand side, then we would move everything over to the left-hand side, and we would make the right-hand side equal to what? What would we want the right-hand side to be equal to? 0. Ryan, you got it. And Rahik and Noah. Awesome. So that's going to give us 5x squared minus 2x plus 17. Your A is always the number in front of your x squared. Your B is always the number in front of the x. And then the C is always the number that we call the constant, the term that doesn't have a variable. Again, that's just something that we need to know in order to use the quadratic formula. And I will tell you that if any of y'all are thinking about being engineers, my son tells me I use math every single day. And he prefers the quadratic formula over factoring because he just says it's a formula and it works better for him. So that's definitely, anytime you're solving a quadratic equation, Tyler says, yes, that has an x squared. It has to have an exponent of 2 in order for you to use the quadratic formula. So that's something that he has used for a long time. Looking at this week at a glance, Monday, we had a 3.12 unit test, part 1 and part 2. If you're in Honors Algebra 2, you have the part 2. That's the TGA. I am grading TGAs every single morning. So hopefully if you turn it in, you're going to see, hey, it's been graded, and I'm putting feedback and everything. So make sure that you go back and read the feedback. Yesterday, we started Unit 4 with 402. Today, we have 403. Tomorrow, we have 404. And then Friday, we can take a big breath and we can have a catch-up day. So definitely feeling like that's a good thing to me. Remember that you can use your notes. You can use your whiteboard decks if you like to save those. And you can go back and watch recordings of anything that you might struggle with. And you can definitely go back and look through your OLS. I did want to give a little shout out to my Bitmoji classroom in case you have forgotten that this is here. It is located in the announcements, but it's getting shoved further and further down as I make the announcements for each week. So I would probably suggest that if you're looking for anything that's in my Bitmoji classroom, that you go to content. So I'll show you really quick. I'll just pull up one of my classes. And if you go to content at the top, OLS is feeling as slow as we are. Right underneath the table of contents, the very, very first thing says Ms. Prater's Bitmoji Classroom. And then you can click on that link. And then inside this, it's just a Google slide. If you're in Honors Algebra 2, let me go ahead and say this because this is going to connect to your first semester Honors Algebra 2 project. So make sure you don't freak out. This is for Honors Algebra 2 only. You have a project each semester. That's part of why Honors is a little bit harder than regular. But your Honors project, actually both semesters, is to one of the things you have a choice between creating your own Bitmoji classroom, which is just a Google slide, where the first page, you make it however you want it. It could be any theme. Mine just looks like a classroom because I'm a teacher. And you can go ahead and go to the Honors project, look at the requirements, but you have to have at least 5 links, active links. Like if I click on this unit resources, it's going to take me to another page. Okay, it could take you a page. It could take you to a video on the internet. It could take you to a Kahoot game. And here are some videos for each unit that we cover in semester 1. I also have the links to all the whiteboard decks that I send out. So here's all the whiteboard links. If you ever needed to go back and find a certain whiteboard deck. Yep, you got to do it for both semesters if you're in Honors. If you're in a small group, then the whiteboard links are there. What else do I have? I have some calculator tutorials. If you click on this live link, it takes you to some calculator tutorials. I have exit tickets. These are all the whiteboards links that I sent out where they were exit tickets. And then I have a Google form link right here. So I think there's about 5 things if you're in Honors Algebra 2 that you have to have on your Bitmoji classroom. So Honors Algebra 2 students only, because I know y'all are mixed in this class with Honors and regular. So I'm kind of talking only to Honors right now. So your project is the same for both semesters. So you either make a Bitmoji classroom like this one, or you make a 45-minute lesson video. And the 45 minutes is a long time to video yourself teaching a lesson. So I will tell you just by experience, most of my students pick the Bitmoji classroom. We will have some help sessions built in specifically for Honors Algebra 2 students as we get closer to when that project is due. I don't think it's due until I don't know. I can tell you like end of November. Somebody might know. Honors project is due December the 2nd. So you still have quite a while, but just as I'm just mentioning my Bitmoji classroom, it might help you get an idea of how to create one. But I'll do some extra classes leading up to when that's due. Yeah, 45 minutes. Yeah, most of my recording software that I use is free. And so since it's free, it has limitations and I can only make a 30-minute video. So most students pick the Bitmoji classroom. Now you do have to have a 10-minute video, lesson video, something that we covered this semester. But 10 minutes is like nothing. You can already have some slides built in and you can just talk about the slides. You don't have to show your face. That's always a question. So do I have any honors Algebra 2 students that might have any questions? I'm looking back. You can submit them now. Whoever asked that, I think that was Noah. You can submit them now, but just make sure you understand the rubric and you understand the assignment. And again, we'll talk about it more as we get closer to, probably the first part of November. I'll do some help sessions and then you can just make sure you're on track. Or you can just email me if you want to read the assignment requirements. But it is a 100-point assignment. So we're talking to honors Algebra 2 students only. It's the same exact project, both semesters, except you have to pick something that we covered first semester for the first semester project, and you have to pick something that we covered second semester for the second semester project. So once you get your Bitmoji Classroom, if that's what you choose, built for your first semester project, you can use pretty well the same Bitmoji Classroom, but you may have to change a few things inside of it based on second semester's topics. But anyway, I wanted to do a little commercial about my Bitmoji Classroom. Basically, Ryan, a Bitmoji Classroom for first semester, it has to have a unit that from first semester, and then you have to pick a topic. Has to have 5 live links, has to have a 10-minute video. So your video will be on something, your first semester project, your video will be on something that we covered first semester. And then your second semester project will have a video that you covered with something that we covered second semester. Oh, this one's kind of fun. Miss Peters is another teacher that teaches Algebra 2, and she just suggested that it was a project that she always did. I actually like it. If we were in person, y'all could work on it some in class, and I would help you. A lot of students don't know how to put live links into a Google slide, and that's something you definitely need to learn how to do. So just making a Google slide with information in it, I can see that being helpful for other presentations or for the future that you have to do. So today we're going to look at 2 methods of long division, and I'm going to actually try to take you back to the 4th, the 5th, or the 6th grade. I'm not sure where you did long division. Does anybody remember what grade you were in when you did long division? I'm going to open up just a blank Kami page because I really want to take you back to the 4th, 5th, or 6th grade. 4th. I think I remembered doing long division in the 4th grade. So if you don't know what in the world I'm talking about, so I'm going to make up something that you probably did in the 4th grade. So let's do something like 7 divided into 51,233. Okay, so that kind of problem. So y'all still thinking 4th grade? Those of you, when I said long division, you knew exactly. You saw a picture of it in your head. Mine says 4th grade. 3rd grade, Xander? Wow. I would think 3rd grade. I definitely did not learn this in 3rd grade because what I remember about 3rd grade is multiply, 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 multiply. That's what I did the whole time in 3rd grade as far as math. Okay, so I like to take you back to when you did long division because the steps of long division are going to be the same for long division with polynomials in Algebra 2. So I get to have the wonderful job of showing you how to do long division with polynomials. So I do this every single time I teach this in Algebra 2. I take you back to some background that you should have, okay? Or hopefully you have, or hopefully I'll uncover some memories from your background, okay? So you got your number outside the house. Okay, so when we talk about outside the house, we're talking about 7. Okay, and then the number inside the house, we're talking about the 51,233. So what you're dividing by is always outside the house. What you're dividing into is always inside the house. Maybe your 4th or 5th grade teacher didn't use these terms. And then your answer is going to be on top of the house. So y'all give me a yes in the chat. Is any of this, you got any memory of this uncovered? Pull the cobwebs out. Okay. Big Wolf and the pigs. Okay, dividend, divisor. So if we get kind of fancy with our vocab, the 7 would be called the divisor. The 51,233, y'all know what it would be called? What's inside the house? It's called the dividend, and I hope I'm spelling this right. Yeah, Tyler, you got it. Dividend. I'm a horrible speller. I think that's how you spell it. And what do we call the answer? It starts with the letter Q. Yep, Melanie's got it. Quotient. So I do think I still say outside the house, inside the house. It just makes a little bit more sense. But the divisor's outside, the dividend's inside, the quotient is the answer, and it's on top of the house. Okay, cool. So what do you do first? Going back to 4th and 5th grade, these are the same steps that we're going to use with long division of you put 7 into the 3. Okay, you may not can read my writing, Noah, but this is a 5. So we say, will 7 divide into 5? Yes or no? Nope, 5's too small. Tyler says nope. So then we say, will 7 divide into 51? Okay, 7 times, Xander said. So we put that 7 on the top. Okay, so I'm going to write this step. My first step is divide. My second step is, what do I do next? So 7 goes into 51 7 times. Do I subtract next? You are right about the subtraction. I have to multiply. So I'm going to write multiply. So I do 7 times 7 is 49. And then my next step is subtract. So 51, minus 49 is 2. And then what's my next step? What do I do with this 2? I bring it down. So my 4th step is bring down. I'm going to just do a little arrow and then repeat. Would you agree with that? Those are my steps in long division. Divide, multiply, subtract, bring down, repeat. Okay, those are the same exact steps, except it's going to be much more complicated or more complicated because we're going to have variables in our polynomial. We're going to have exponents on our variables. Okay, so let's finish this up. Let's do it again. 7 divides into 22. 3 times. 3 times 7 is 21. 22 minus 21 is 1. Bring down the 3. Do it all over again. 7 divides into 13. 1 time, y'all are ahead of me. 1 times 7 is 7. 13 minus 7 is 6. Bring down for the last time. So when you bring down for the last time, you're dividing for the last time. Oh, I wanted to have a remainder, dadgummit. 7 goes into 63. I just made this up off the top of my head. 9 times. 9 times 7 is 63. Subtract, and the remainder is 0. Okay. We will probably have remainders most of the time. Okay. So can we pretend we had a remainder here? Can we just pretend for just a second? So let's pretend we had a remainder of 5. Let's just pretend. So what I remember from 4th grade is we used to get to write a big R and then we got to put a 5. That's how we started long division. Okay. But what the 5 really represents, if that was just a made up 5, I didn't have a remainder. I wanted to show you. So what you really do is you take the 5 and you put it over, anybody know? You put it over your divisor. So you really have 7,319. And if I had a remainder of 5, I know it was 0, but I just wanted you to see what you do with the remainder. You put the remainder back over what you're dividing by. So today we're going to look at, and if you've not already looked at section 403, we're going to look at this same exact process that you learned in 4th and 5th grade. And I know my husband revisited it when he subbed for 6th grade for 6 weeks because I had to remind him how to do long division. I know that they refreshed their memory of it in the 6th grade. So I wanted you to see that you've done this process before. So I don't want it to seem like something totally new. Okay. So back to my first slide. Oh, I have a choice activity. Totally forgot I did this. You can go through the examples with me today. You can work on some you try on your owns. They are on slide 12 with the answers on slide 13. So I can show you that really quick. If you've already gone through this lesson and you don't think you need any extra help, you can try some on your own. Some are long division, some are synthetic division, because I'm going to teach both of these today. And then the next slide has the answers. Or you could do the challenge problem that's on slide 14, and it also has the answer on slide 15. So a lot of times, not a lot of times, I'd say maybe 50% of the time, I might give you some choice activities just based on the lesson. All right, so totally up to you. You don't have to tell me that you're not sticking with a lesson. If you want to go ahead and do one of these other activities instead of go with me through the lesson today, and you want to also do the exit ticket, there is also an exit ticket that you can do. Any questions before I actually show you all how to do long division with polynomials? All right, cool. All right, so here we go. We have this pretty ugly looking problem. I'm going to be transparent. It looks awful. It's this polynomial divided by this other polynomial. And we have to set it up. So here's the vocab. Y'all just talked me through that from 5th grade, 4th or 5th grade. We've got our divisor on the outside, our dividend on the inside. We got our quotient, which is our answer, which will end up being on the top. And if we have a remainder, it'll be the last thing that we get when we subtract from the very last time that we multiply. So we have to take this problem. We have to take what we're dividing by, and we have to put it outside. That's our divisor. So we're dividing by the binomial x minus 3. We're dividing into x cubed minus 11x squared plus 31x minus 17. Now, let me tell you some things that maybe, I don't know if your OLS was clear about, if you haven't done the lesson yet, but you do have to make sure, and this is something that I taught y'all in Unit 3, you always need to write your polynomials where the highest exponent term is first. And then you're going from x cubed, next term x squared, next term x to the 1, last term constant. In the process of doing long division, let's say you don't have an x squared, then you would have to put in a plus 0x squared. So if you just had x cubed plus 31x minus 17x, for this process to work, you would have to have a placeholder for your x squared. That's true for long division, and it's also going to be true for synthetic division. So think about this. Think about if you got your first paycheck and you were supposed to get $503, but you only got $53. How important is that zero? Even though it's zero, it still holds the place value. So just think about that in the fact that if you have a zero in between two numbers, it holds that place and it's important. So you'll see at least one example of where I have to put in a zero placeholder because a lot of times you just miss that when you go through your online class, and that's something that you may not understand. Okay, so I have everything, and I know I have every term because I have x cubed, x squared, x, and then a constant. So I'm ready to divide. All right, so when you divide using polynomials, this is the part that's different from 4th and 5th grade. So in the 4th and 5th grade, we just had one number outside. Most of the time you're going to have two. And when you divide, you only use the first term to divide. Now, I've written the steps: divide, multiply, subtract, bring down, repeat, just like we did on that practice 4th grade problem. So we're going to say x divides into x to the third how many times? Or x times what is x to the third? You can think of that as two different ways. And remember, this is x to the understood power of 1. So what would I multiply x to the 1 by? You're not looking at this minus 3 yet. That's going to come when we multiply. So x times, Tyler's got it, x times x squared. So when I divide x to the third by x to the 1, I get an x squared. So I did the divide part. Then I multiply. So when you multiply, you take what's on the top and you multiply it times both of these terms. This is where you use the minus 3 in the multiplication step. So you're going to do x to the 2 times x to the 1, which is x to the 3. And then x to the 2 times negative 3, which is negative 3x squared. And you're going to make sure like terms are lined up, because my next step is to subtract. And we want to make sure that we're subtracting like terms. So my next step is to subtract. And I always like to put what I got when I multiplied in parentheses, because not only are you subtracting the x to the third, but you're also subtracting the negative 3x squared. Draw my line, and then we're on the third step, subtract. So we're going to do x cubed minus x cubed. Those should always cancel if you have multiplied and divided correctly. The first term should always cancel. Then you're going to do negative 11x squared, subtract negative 3x squared. Subtracting a negative is really adding a positive. So that's going to be negative 11 plus 3. So that's going to give me negative 8x squared. That's the subtraction step. And then the fourth step is to bring down the next term, which is going to be positive 31x. And then repeat. So now it's time to divide again. Hey guys, y'all stay on track. X to the 1 goes into negative 8x squared, or x divides into negative 8x squared. How many times? X times what is negative 8x squared? Have I lost everybody in the room? Oh, nope, got 2 people with me. Negative 8x, y'all are correct. That's the division step. Now we take the negative 8x and we multiply it times the whole entire divisor. So negative 8x times x is negative 8x squared. Negative 8x times negative 3 is positive 24. Put what you just got when you multiplied. That should be a 24x. Subtract. Negative 8x squared minus negative 8x squared. The first term should always cancel when you subtract. And then 31x minus 24x gives me 7x. Bring down my last term. So this will be the last term I divide. X divides into 7x how many times? Positive 7. So put plus 7 on the top. Now we're ready to multiply. 7 times x is 7x. 7 times negative 3 is negative 21. Put those terms in parentheses. Subtract. Remember, subtraction's like the devil, and it'll cause you to make mistakes. So be really careful here. 7x minus 7x will cancel. And then negative 17 minus negative 21 is really negative 17 plus 21. So my remainder is going to come out to be 4. Take your remainder, bring it up to the top line. If your remainder is positive, you will write plus. If your remainder is negative, you will write minus. And then you'll take your remainder and you'll put it back over what you're dividing by, or what's outside the house, which is x minus 3. And then this is your answer. This is your quotient. Okay. Now, just kind of, that's a whole lot of stuff. Let that kind of only have 4 examples. Let that kind of just soak in for just a second. I'm going to do 2 long divisions and 2 synthetic divisions. You're always subtracting, yes. It's always divide, multiply, subtract, bring down, repeat. Divide, multiply, subtract, bring down, repeat. The signs are going to change when you subtract, absolutely. All right, anybody else have a question? Again, we're going to look at 2 long divisions, 2 synthetic divisions. That's why I think it's important Tyler says he's glad that it follows the same process of what you learned in the 4th and the 5th grade. Not everybody will show you that as an intro, but it's very helpful. Okay, we're doing this one by long division again. So we're dividing by x minus 2. It's going to go outside the house. This time I have an x cubed and an x squared, but I don't have an x. So this is where you'll have to put in a 0 for a placeholder. So you'll have x cubed minus 2x squared plus 0x minus 4. And they're not going to put plus 0x in the problem. So you're going to have to know to put any term that's missing, you're going to have to put in a 0 there. Destiny said, so a lot of math is based on what you learned in elementary school, but y'all know the thing about math is it just keeps getting a little bit harder, but we still have that foundation from elementary school that we can go back on. Okay, all right. When we're dividing, remember that we use only the first term of our divisor. We only use this minus 2 in the multiplication step. So we're going to say x times what is x cubed, remembering that this is x to the 1, x squared. So we'll put that on top of the house, and then we're going to do x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Put what you just got when you multiplied in parentheses, so you're more careful when you subtract. So you're going to do x to the 3rd minus x to the 3rd. That's going to cancel. And this doesn't always happen, but I wanted you to see this because this is confusing to me. But when you do negative 2x squared minus negative 2x squared, those are going to cancel also. So technically you get 0x squared. I just want you to continue to do the multiplication. Sometimes the zeros get people confused. So just put in 0x squared, bring down the next term. To me, that's probably what I would do that makes the most sense to my brain. If you've got another way and you can always get the right answer, then definitely do your way. So then we're going to go x divides into 0x squared. And this is just going to be 0x. This is almost going to be like, why am I doing this? But I'm just trying to show you how everything lines up. 0x times x is 0x squared. 0x times negative 2 is plus 0x. Parentheses, subtract, cancel, cancel. Bring down 0x and then bring down your last term. And x times what is 0x? That's going to be a 0. 0 times x is 0x. 0 times negative 2 is 0. Put that in parentheses and subtract. And what's our remainder going to be? Negative 4. So if your remainder is negative, excellent. Tyler's already got it. You bring it up to the top. You write minus. And then you take your remainder and you put it back over the whole divisor, which is the x minus 2. Now, do you think we're going to see x squared plus 0, x plus 0, minus 4 over x minus 2? Do you think we'll see that in a multiple choice situation? No, you're just going to see x squared minus 4 over x minus 2. That's how you would see it. Even though it's okay to have the plus 0x and the plus 0, I just wanted you to understand how everything always lines up. If something's not lining up, meaning you don't have x cubes here, you don't have x squareds, that means you've done something wrong. So everything should always line up. Okay, that's my last example for long division. And then I'm going to show you a shorter way called synthetic division. And you'll have choices sometimes whether you want to do it with long division or whether you want to do it with synthetic division. I'll tell you my students are pretty well 50-50 in the past on which one they would rather do. So Noah says, so we'd put x squared minus 4 over x minus 2 as the final answer in the OLS. I would not put the plus 0x plus 0 because I'll tell you what I found out about the OLS that I'm sure y'all already know. Sometimes the OLS doesn't put all the possible answers in there, and so you don't always get credit for something that is technically correct. So I would go with not putting the plus 0x and plus 0 in the OLS. Yep. Whoever built the OLS didn't take the time to put all the possible answers. So a lot of times students will email me on a quiz when they'll go, I thought I got this right. And it's just one tiny thing, which is technically correct, but the OLS didn't put that version in. So if you ever think you have something right and the OLS marks it wrong, just take a picture of where it has the wrong and the correct, and then send it to me, and I'll just override. I'll just put your grade in. I'll just give you that problem back. So nothing is better than humans, guys. You can't replace human interaction, because I can tell what you mean sometimes when the computer doesn't. Okay. All right. Now I'm going to teach you something that you didn't do in elementary school. Okay. So when you think about the word synthetic, let's just think about the word outside of the context of math. What does synthetic mean to you? Like, forget about math for just a second. But what does the word synthetic mean? Blair says fake. Rahik says made up. So it's a fake way to do long division. So somebody with all the time on their hands, years and years and years ago, found a fake way to do long division. Okay. It gives you the same answer, but I think about synthetic material. So maybe something that's fake leather. That's like fake leather would be synthetic. It would be made of something that's not real. So this is just a fake way to do long division that is shorter. So it does have different steps. The steps are written down here. Step number 1 says take your divisor. So we're going to take our divisor, which is the p plus 1. And we're going to set it equal to 0. And we're going to get p is equal to -1. So you have to do that first every single time. Step number 2, we're going to remove all the variables from the problem. And our house is going to look different. So do y'all notice this kind of looks like a backwards L here? So our little house that we had in long division, it's actually going to look like this. This -1 that we got when we set our divisor equal to 0, that's what's going to go outside of our house. And then the house is kind of just to the right of that backwards L, and we're only going to use our coefficient. So we have a 1 for our p cubed, we have a 6 for our p squared, we have an 11 for our p, and then we have a 16 for our constant. All right, I'm going to let you think about that for just a minute, and I'm going to ask my husband a question. Hold on just a second. All right. Any questions so far? If it helps y'all at all, I personally like synthetic division over long division because I think it's easier. It's different. Yeah, it's different. So some of y'all you're gonna have to just figure out what you think is easier to you. Okay. All right, so let's see where we're at. Number 1, set the divisor equal to 0 and solve. This number becomes your divisor. So this -1 becomes our divisor. Step number 2, remove all the variables from the dividend. So what we're dividing into, we remove all the variables. That's the part that I like, is that we don't have to do the variables. Okay, this is the weird part. Hang with me. 3 says bring down, multiply, and repeat. Okay, so what you do is you take the first term, you bring it down, you put it under the line. Every single time you do synthetic division, you take the very first coefficient, you bring it down, you put it under the line. And then you multiply 1 times your divisor, 1 times -1. You put that number underneath your next coefficient. And then you combine those numbers. So one reason I like synthetic is we don't subtract in synthetic. We just combine. So 6 and -1 combine to be 5. And then I just repeat. 5 times -1 is -5. Write -5 under the next coefficient. Combine. 11 and -5 combine to be 6. Repeat. 6 times -1 is -6. Combine. 16 and negative 6 combined to be 10. And the last number that you bring down is always your remainder. Rick's already got 10. Okay. So think about that. That's totally different steps than long division. All right, that's my third step. So I'm going to write my third step right here. Okay, excellent question. Noah says, what about the variables? We know we got to have the variables in the answer. Okay, that's in 4. Step 4 says you're going to subtract 1 from your highest exponent. So in our dividend, our highest exponent was p to the third. So we're going to subtract 1 because we're dividing p into p cubed. We're dividing this p into the p cubed, and that's going to decrease that highest exponent by 1. So that's going to give me a p squared. So this first number I have is going to be the coefficient of p squared. The next number is going to be the coefficient of p. The next number is going to be your constant. The last number is always going to be your remainder, and it always goes back over what you're dividing by. 4 minutes are left. Thank you, TJ. I'm almost done. And then again, you don't have to have this 1. You probably won't see it in the answer. I'm just showing you that if this is p cubed, this will be 1p squared, 5p, 6. If this were p to the 4th, then this would be p to the 3rd, p squared. It would go like that. All right, let me do one more synthetic division, and that's my last example. Okay, so my first step is to take my divisor, which is x plus 4, set it equal to 0, and solve. What I get for x is going to be my dividend. So the negative 4 is going to be my outside number. I remove all my variables, and I use the coefficients only. So I have 1x cubed, 4x squared. I don't have an x term, so you have to put the 0 placeholder, whether you're doing long division or synthetic division. That part is consistent. And then you have the negative 8. So just double check. 1x cubed, 4x squared. I don't have an x, so I have a 0 there, and then I have the negative 8. You're going to leave this line blank, and then you're going to draw your line, and then you're going to follow your steps for step 3. So the first step is to take your first coefficient, bring it down, put it under the line, and then you start your process. 1 times negative 4 is negative 4. Combine gives me 0. 0 times negative 4 is 0. Combine, that gives me 0. 0 times negative 4 is 0. Combine, that gives me negative 8. And negative 8 is the last number that you bring down. That's always your remainder. Step number 4, we go to the highest exponent. We subtract 1. That means this first number that you have under your line is the coefficient of x squared. The next coefficient is the coefficient of x. The next number is just your constant. The last number is always your remainder. And then you always put it back over what you're dividing by. And just like that second example, your final answer, you won't use these 0 x's and zeros. You'll just do x squared minus 8 over x plus 4. Questions or comments? I'm at 9:59. What about that? Bam. All right, what you think? 1, I got it. 2, I'm almost there, but not quite. 3, I don't get this at all. This is the dumbest stuff I've ever seen. All right, y'all just got to practice, practice, practice. There might be some funky problems that might have decimals or fractions, but the process should still be the same. Awesome. All right, don't forget to download your whiteboard if you're somebody that likes to download and keep your whiteboards, because I have all that information. And then if you want some bonus points, I will do all your exit ticket bonus points at the end of the quarter, which will be October the 11th. Tell me what you think is easier, long division or synthetic division, and tell me why to grab some bonus points. And y'all have a wonderful Wednesday. Always like to use that because that's alliteration. Wonderful Wednesday. Let me know if you have any questions. Remember, we do have optional help today at 2:30. You could pop in if you're needing help with anything. If not, Reading Rainbow. My kids love reading. I love the guy. What's his name? I can see his face. He's been on several really good shows. He's a great actor, the person that did Reading Rainbow. Reading Rainbow. LeVar Burton, I think. Maybe. Bye, guys. Y'all have a good day. Let me know if I can help in any way. Show up at optional help today at 2:30 if you need some optional help. If not, I will see y'all Monday. Maybe. Definitely. Hopefully. Y'all have a great day. Bye, guys.